If the working fluid inside an engine, if it is used a gas or air, then that is called gas power cycle or air standard cycle. Where this air or a gas, what it is used as a working fluid, results in a power generation. Power generation, it may be in a closed cycle or it may be in an open cycle. So this is called gas power cycle. Now after discussing this gas power cycle, for analyzing the each gas power cycle, we have to go for some assumptions. This assumption is meant to increase the efficiency of the each cycle. Now the cycle, theoretical cycle, or it may be any applied cycles, which gives you the efficiency less during working condition, that can be enhanced to maximum efficiency by taking some assumptions. What are those assumptions? There are three assumptions. The three assumptions, like what the working substance we use, that should be air or gas, and it should obey the gas laws, and specific heats are constant. Where the engine, what it is working, it should work under closed cycle. And in the engine, there are mainly 4-stroke, and that 4-stroke, inside that main 2 strokes, we have compression and expansion. This 2 strokes or 2 process should be always adiabatic. So during this process, when it is adiabatic, that is completely engine should be insulated. That we have come across with Carnot cycle, how it becomes adiabatic and internally reversible. So after all assumption of the cycles, we go across with the first cycle called Carnot cycle. Now we were discussed this Carnot cycle is a standard cycle or hypothetical cycle. Describes series of events. So where the main 2 strokes being taken into consideration over here, the 2 strokes are compression and expansion. Why? Because compression and expansions are the 2 processes results in the work output. So first 1 to 2, we take an piston at TDC position. When it moves up to the half of the cylinder, so it will be an expansion process. During that time, the heat source being brought into the cylinder head, means there is a heat transfer from heat source to the air present in the cylinder. So first of all, we have to take in a cylinder with the air as a working fluid. We have a 3 parameters or 3 resources. The 3 resources are heat source, heat sink, and as well as insulating cap. So now heat source being brought near to the cylinder head, the heat transfer occurs from heat source to the air. So there is an expansion process. The piston start moving from TDC position to off of the cylinder position. Once it reaches to the off of the cylinder position, immediately heat source being taken out, insulating cap is being brought nearer to the cylinder head. Why insulating cap is brought? Because to maintain the adiabatic condition, as we have to assume the expansion and compression process is adiabatic condition. Adiabatic can be happened only when it is insulated. So we will bring the insulating cap near to the cylinder head. Now after this, it becomes a adiabatic condition. So further still, the piston will start moving from off of the position to the BDC position as adiabatic condition. So that's why 1 to 2 is isothermal expansion, where heat transfer occurs from heat source to the air at constant temperature without changing in its temperature. So from the source to the cylinder or source to the air, the temperature without changing temperature, the heat transfer occurs. So that process is called isothermal expansion. Now adiabatic expansion, because insulating cap is kept nearer to the cylinder, it becomes the further process with adiabatic condition. So next is adiabatic expansion. Further, once BDC it reaches, we will bring heat sink to the cylinder head. So when we bring the heat sink to the cylinder head, what happens? Heat sink to the cylinder head. Similarly, the piston will move from BDC to TDC. Why? Because the heat absorption occurs from inside the cylinder to the heat sink. Sink is the absorber. So as there is an absorption, so what happens? There is a compression process. Now compression process increases in its pressure and volume, makes 3 to 4. Once the piston reaches off of the position, so we have assumed compression process is also adiabatic condition. So that's why we will take out the heat sinks and bring again insulating cap for next further half of the position piston movement. So this will become the compression adiabatic. So that's why adiabatic compression is for next conditions. So after taking these four conditions or four process for mainly two strokes, so we will go with the TS diagram. You know 1 to 2 is isothermal, temperature is constant, so 1 to 2 is a straight horizontal line. Adiabatic, for all adiabatic and isentropic, entropy remains constant. As entropy remains constant, 2 to 3 comes down. Meanwhile, expansion process, temperature decreases. 3 to 4 isothermal, temperature constant. 4 to 1 adiabatic, entropy remains constant. So completing the TS diagram, T1, T2 is the higher temperature, T3 and T4 is the lower temperature. We go for a further process equations. So each process have each equation, work done equation, heat transfer equation, heat supply equation, and heat rejection equation. That we will write it here. Now, first isothermal expansion. You know all isothermal expansion, the amount of heat supply is equal to amount of work done. Means in isothermal, as there is a temperature constant, the amount of heat is supplied to the system, that much amount of the work done takes place. That's why Qs is equal to work done is equal to P1 V1 ln of V2 by V1. Where P1 V1 is taken as MRT1, that's why this will become Qs is equal to W1 to 2 is equal to MRT1 ln of V1 V2 by V1. Always take this as one condition. Similarly, for adiabatic condition, this was the formulas. You need to keep remember these formulas for each and every process so that problems become easier and easier for you to solve. So heat supply in adiabatic will be 0. Work done is P2 V2 minus P3 V3 by gamma minus 1. Always we take P2 by P3 is equal to V3 by V2 to the power of gamma. How? Because the process of adiabatic says PV to the power of gamma is equal to constant. Also, we can take adiabatic process as PV by T because MR is constant. So as there is two points for the process 2 and 3, we write P2 V2 by T2 is equal to P3 V3 by T3. So taking this all equations, next is isothermal compression, heat rejection occurs. So heat rejection is equal to amount of work done MRT3 ln of V3 by V4. Similarly, adiabatic compression, the same equation but different points been mentioned over here. Finally, the thermal efficiency of the Carnot cycle is calculated. Thermal efficiency of Carnot cycle is the ratio of network done to the heat supply. Network done to the heat supply. Network done is heat supply minus heat rejected. So finally, I can write thermal efficiency as, so thermal efficiency as 1 minus QR by QS. So QR and QS we get it from equation number 1 and equation number 3. So substituting equation 1 and 3 to this equation, we get like this. MR cancels. Where we can also cancel V3 by V4, V2 by V1. Only when I prove V3 by V4 is equal to V2 by V1. How can I prove this? Simple. Assume the second equation or consider the second equation. Second equation was this from the adiabatic condition. This I will write in the form of like this, because T2 is equal to T1, T3 is equal to T4 in the TS diagram that we all seen. As isothermal temperatures are constant, instead of T2 I can write T1, instead of T3 I can write it as T4. So observe the equation 7 with the equation 4. So where here it is a T4 by T1, here it is a T1 by T4. So both are reciprocal. So as there is reciprocal, these are reciprocally equal. V1 by V4 is equal to V3 by V2, I will write it as V2 by V3, reciprocal of this V2 by V3 to the power of gamma minus 1. As these two prove same, so that is V3 by V4, V2 by V1, as these two prove same, equal, I can cancel out V3 by V4, V2 by V1. Same thing I will do, the remaining the equation is thermal efficiency 1 minus TL by TH, that is T3 by T1, T3 is lower temperature, T1 is higher temperature. Like this way, we had a thermal efficiency equation for gas power cycle called Carnot cycle. So now let us solve the problems on Carnot cycle. 1, 2, 3 problems we have. Let us solve it, and the problems derivations. What we had over here, the same way we have a problems and derivations on other 4 cycles. Totally 5 cycles present on this gas power cycle. So one cycle we will be completing today. By even 3-4 classes, I will be completing all other 4 cycles. So that much better completing the 4 modules. So next, yeah, I think we all know there is a last working day of this semester is June 15th. It's been extended from May 30th to June 15th. Further, we will get so many classes, so we can complete this module very easily. Once after this completion, I go for gas turbine and I will complete even the gas turbine. So, problems on Carnot cycle. Is this notes I have sent to everyone in the group? Gas power cycle notes?
No, sir.
No, sir.
Kalsilva?
No, sir.
Yeah, okay. What I do, I will send it now so that for you people it will become easy to glance it. Give me a second. Before that, write down this problem. As this is the first class, I will leave you to write down. So next classes, as the notes is sent to you, all the problems I read it and go. Please note down this problem. Yes, sir. What the problem says. See, usually the problems on IC engine as well as on the Carnot cycle, the data to extract from the problem will be a very big. So please take your own time to read out the problem and take out the data. The data for this Carnot cycle, usually not only Carnot cycle, in all in whatever the cycles you have in the chapter, the data can be extracted very easily once you know the complete cycle. Your cycle's PV diagram and TS diagram, it should come into your mind once the problem is recognized to which cycle it belongs. So once after recognizing, the higher temperature, lower temperature, higher pressure, lower pressure, all things it should come into your mind. So the data extraction becomes easier for you. Now let us glance this problem. After glancing, let me take you to the PV and TS diagram for writing down the data. Without PV and TS diagram, writing the data in whatever the cycles of gas power cycle chapter, it is impossible. So always you need to remember PV and TS diagram, and even more, once PV and TS diagram is written, you will awarded with the marks. Some marks, part of the marks from the problem. Now let us read out the problem. 0.5 kg of air. Keep it in mind, it is a m value as given is a mass of the air. Executes a Carnot power cycle S, given or mentioned it as Carnot power cycle, having a thermal efficiency of 50%. Yes, this also a general, no need to glance it with PV and TS diagram, you can take down directly. Thermal efficiency is 50%. So that is what they are written. Mass is 0.5 kg, thermal efficiency is 50%. Next, heat transfer to the air during the isothermal expansion is 40 kilojoule. At the beginning of the isothermal expansion, the pressure is 7 bar and the volume is 0.12 meter cube. Now, it's very important, you people, to keep remember, or you have to write down the PV and TS diagram to take down the data very easily. What the problem says, the heat transferred to the air. Now observe, the heat transferred to the air during isothermal expansion. Now let us go for PV and TS diagram. Which is isothermal expansion? 1 to 2 is isothermal expansion. So heat supply always occurs in isothermal expansion. That's why it is QS 1 to 2. QS 1 to 2. 1 to 2 is isothermal expansion. The given data is heat supply during isothermal expansion. Therefore, you can write the data as QS 1 to 2 as 1 to 2 as 40 kilojoule. That's what I have written QS. Next, at the beginning of the isothermal expansion, now check out isothermal expansion, here it is 1 to 2. Beginning of isothermal expansion point is 1. Beginning of isothermal expansion is 1. So now the data belongs to the 1. The point 1 is the data or is the value given in the problem. Beginning of isothermal expansion. The pressure is 7 bar. So beginning of isothermal expansion is 1 point. Pressure is some bar. So that is 7 bar. So that's why I write it P1. This is how you identify this given is a P1 or P2 or P3 or P4. So if the beginning of isothermal expansion, then it is P1. Next, after that, the pressure is 7 bar and volume is 0.12. Not only the pressure, they have given the volume also 0.12 meter cube. Therefore, it is a V1, taking down V1 0.12 meter cube. Now, what we have to find out, maximum and minimum temperature of the cycle. Look out the TS diagram. Maximum temperature is T1 and T2. Minimum temperature, that is T3 and T4. Lower temperature is minimum temperature. Higher temperature is maximum temperature. That these 4 values we have to find out. Means if you find out 2 values, that will be equal to another 2 values, so that we can easily finish it up. The volume at the end of the isothermal expansion. Isothermal expansion is 1 to 2. Beginning of isothermal expansion is 1. Ending up of isothermal expansion is 2. That's what they have given. Volume at the end of isothermal expansion. At the volume at the end of isothermal expansion, we have to find. Therefore, I have to find V2. Check out. I have to find V2. Next, the heat transfer for each of the 4 processes in kilojoule. I have to find heat transfer for all the 4 processes. So already QS is given 1 to 2. We have to find out Q of 2 to 3, Q of 3 to 4, Q of 4 to 1, all. So that's why I have written Q of 1, 2, 3, 4. We have to find. After taking down the data, hope you have understood how to take down the data. Once after write down the PV diagram, here give isothermal compression. Beginning of isothermal compression is 3. Ending up of isothermal compression is 4. Like this way, the values are taken. Now, after writing PV and TS, for every problem, must and should the PV and TS diagram should be written. So, because usually the problems on gas power cycles, it comes from 10 to 15 marks, and 2 marks always it is awarded for the data, so not data, for PV and TS diagram. So once after taking out the data, let us find out one by one. What we have to find out at the beginning? I have to find maximum temperature T1, minimum temperature T3. So how do you find? We can find it very easily. To find maximum temperature and minimum temperature, usually you have to glance the formulas, whatever you had. Wait a second, I will come back to it. Sorry for the inconvenience. We have to find out the maximum temperature and minimum temperature. So for that, we doesn't add any formulas where it contains a temperature. Go for the further first process, isothermal expansion. What was the first 1 to 2 process? Isothermal expansion. QS is equal to P1 V1 ln of V2 by V1 or MRT1 P2 by V1 V2 by V1. So using that equation, I would have find it out, but there are little bit data not given in that. So that's why I go for perfect gas equation. For first condition, I use P1 V1 is equal to MRT1. Not only for this complete chapter, if you can't use the formula, you have to use P1 V1 is equal to ln of MRT1, because this complete cycle chapter is of gas power cycle. So always it obeys the perfect gas equation. So for perfect gas equation, I will write T1 is equal to P1 V1 by MR. Now T1 is equal to P1, it is given how much, 7 bar. V1 it was given M, it is 0.5 kg. Or you have to always remember it is 0.287 kilojoule per kg for air, or always vary for vapor, or always vary for air. So this was discussed in psychrometry. This was discussed in vapor core cycle. So same comes over here also, or it will remain 0.287 kilojoule per kg Kelvin for air. You have to keep remember, for vapor it is different, for air is different. For air it is 0.287. Substituting this, we get the value of T1. So from the TS diagram, T1 is equal to T2. That's why I write T1 is equal to T2. Next, to find minimum temperature, we know that efficiency of the Carnot cycle. See, they have given a thermal efficiency value 1 minus T3 by T1. So that's what given in the problem is thermal efficiency. Check out. If I use thermal efficiency, I would have found out two temperatures. But in the two temperature is also is unknown. So one temperature need to be found out. To find out one temperature, I use a PV is equal to MRT equation. After that, once I get a T1 value, I go for the thermal efficiency. 1 minus T3 by T1 I get. Where T1 just now we have figured out, T1 is equal to T2. So substituting that, we get a T3 value. Always mind it. So thermal efficiency, if you are substituting in point decimal, no need to multiply 100. If you are substituting in terms of 50%, you have to multiply by 100, so that it will be equified for the further last answer. So T3 we get it as 292.68 Kelvin, where TS diagram says T3 is equal to T4. That's why I write it T3 is equal to T4 is equal to TL is equal to 292.68. This is the lower temperature we got. This is how we find out the two different temperatures, T1, T2 and T3, T4. Now let us find out the value of V2. How do we find out the value of V2? So V2, very important, mentioned V2 is the point belongs to two process. You can observe 2 belongs to 2 process. 2 is also a part of 1 to 2 process. 2 is also a part of 2 to 3 process. Now 2 is common point for 2 process 1 to 2 and 2 to 3. So very careful. So now I have to find out V2. Either I can use 1 to 2 process formula to find out V2. Either I can use 2 to 3 process formula to find out 2 V2. If it was a point 1 to be need to be find out, I cannot calculate this by using 2 to 3 process. Always I have to go for 1 to 2 processor. So 1 to 2, 2 to 3, where 2 I have to find out. 2 is common for 2 process 1 to 2 and 2 to 3, isothermal expansion and adiabatic expansion. Now how to find out the 2? I will go for the first process 1 to 2. Looking out to the 1 to 2 process, the formula of 1 to 2 process is QS is equal to work done. The amount of heat supply is equal to amount of work done, P1 V1 ln of V2 by V1. Where QS it is given in the problem, it is 40 kilojoule or joule. Yes, 40 kilojoule. That is substituted here. 40 kilojoule when substituted here is equal to P1. It is given 7 bar. Converting it into kilopascal. P1 0.12 given it as 0.12 ln of V2 by V1. So where V1 is again 0.12. So V2 is the unknown. I can find out V2 value, and V2 value what we obtain is 0.193. So like this way I will find out the value of V2. Very careful and very useful for you to be keep in mind. If I want to find out P3, example, if I want to find out P3, go for PV diagram. 3 is the value we have to find out. 3 not only belongs to 2 to 3 process, it also belongs to 3 to 4. So you have to use the formulas of both. Now the both formulas, if I cannot find out by using 2 to 3 process, I can go for 3 to 4 process formula and calculate it. So like this way you will find out the previous process and the next process, keeping that point as a reference. Now after finding out V2, we have to find out the heat transfer in all the 4 processes. Now 1 to 2 process is isothermal expansion, given heat is 40 kilojoule. So first 1 to 2 process heat is 40 kilojoule. What happens to adiabatic process? So you know in adiabatic process there is no heat transfer, therefore the 2 to 3 process heat is 0 kilojoule. Similarly 3 to 4 isothermal compression. So during isothermal compression heat rejection occurs. As there is a heat rejection, so we will write minus 40 kilojoule. So the plus 40 kilojoule is a expansion as there is a heat absorption. So next is a compression as there is a heat rejection. So we will write 40 as minus 40 kilojoule. Next 4 to 1 is adiabatic compression and heat it is 0 because the condition is adiabatic. Simple. So like this way for 4 process we will find out the heat value. Heat value for heat supply is given 40 kilojoule. For heat supply it is 40 kilojoule, heat rejection is minus 40 kilojoule. For adiabatic condition it is 0. This is a simple problem. How do we find out? Please note down it for 2 minutes. Please note down. This hope you have written. Let us go for the next further problem. What this problem says: the maximum pressure. Now, the starting of the problem itself, we have to know the PV and TS diagram, because in the PV and TS diagram only we can find out the value of maximum pressure, maximum temperature. Now, let us go for the PV and TS diagram. So, what was the first line of the problem says maximum pressure, maximum temperature of an air standard cycle. Now, go for PV diagram, we can identify maximum pressure. Go for TS diagram, we can find out maximum temperature. Now, going for this PV diagram 1 to 2, 2 to 3, 3 to 4, which is the value maximum for pressure. Now, observing the diagram itself, we can say P1 is the value which is maximum. So that's why maximum is P1. I write down here P1 as 18 bar or 18 into 10 raised to 2 kilopascal. Now for maximum temperature, coming for TH diagram. So 1 and 2 are equal. So T1 and T2 are the maximum temperature. So therefore I writing over here T1 and T2 are 683 Kelvin. Now after taking down these two values, the ratio of isentropic expansion, so isentropic compression is 6 and isothermal expansion as 1.5. So what they have mentioned here, very important from this problem, you have to keep remember there is a value comes, or there is a one more value added to the problems, is compression ratio. What is compression ratio? Usually you know compression ratio is the ratio of, what do you mean by that? The ratio of compression ratio total volume to the clearance volume. Now the same way you cannot take it over here, sorry, the same way you can take it over here. What is that? The ratio of the total volume to the clearance volume. Now what is total volume, what is clearance volume? That should be understood over here. Wait for a second, the one more PV and TS diagram, if it is written, I will show you. No, just a minute, one more PV and TS diagram, I would have written that compression ratio which is shown. So that will be, check out, this is one more cycle where I have written Vs and Vc. Observe there is a gap from the graph curve to the y-axis curve, that I will consider as clearance volume. Means piston head to the top of the piston head to the cylinder head, the gap what we had, I consider it as clearance volume, because TDC position starts from there. Next, the amount of volume swept by the piston, I take it as swept volume, Vc and Vs. The same way here also, it is considered the Vc and Vs and written. Now observe the ratio of isentropic compression and isothermal expansion. Where you have isentropic compression, yes, isentropic compression to the isothermal expansion. That is what they have shown. Check out the ratio of isentropic compression and isothermal expansion. Compression and expansion, its ratios. So both ratios we have to write down. How do you write it down? Check out the data. How we have written isentropic compression ratio, that is RC, is V4 by V1, and isothermal expansion ratio is R expansion V2 by V1. I go for first isentropic compression. Isentropic compression ratio. So where is isentropic compression? Isentropic compression is here. Isentropic compression comes between 2 points, 3 and 4. So 3 and 4, if I talk, isentropic, it is isothermal. Isentropic means adiabatic, reversible adiabatic, yes. So isentropic or adiabatic compression ratio is 1 to 4. So in these two, which volume is more? Is it V4 volume is more or V1 volume is more? You can observe volume gets increases in this direction from left to right. If the volume comes from right to left, the volume decreases. Now the volume V4 is present here. If I project this to the x-axis, volume V1 will be here if I project this to the x-axis. So 4 comes here and 1 comes at the full line. Now fourth point is the more volume compared to the V1, that is first point, which is less. Therefore, its ratio can become as more to the less. More is V4, less is V1. Therefore, I write it RC is equal to V4 by V1. Means the ratio of adiabatic compression. This adiabatic compression, the ratio they will take. So more volume to the less volume, if I consider, that becomes a ratio. Not only for this, for whatever the process it comes, if you want to take down in ratio in terms of volume, you have to consider more volume to the less volume. You can observe here also isothermal expansion ratio. Isothermal expansion comes 1 to 2. So in 1 to 2, which volume is more? The second volume is more compared to first volume. So that's why I write down V2 by V1 is equal to 1.5. So V2 by V1 is equal to 1.5. Next, after taking V2 by V1 is equal to 1.5, given in the problem, volume of the air at the beginning of isothermal expansion is 0.81 cube, 0.18 cube. Isothermal expansion is this. Beginning of the isothermal expansion is V1. So therefore, V1 value is 0.18 meter cube. So taking down this, what we have to find out? Pressure and temperature at all salient points. We have to find out pressure and temperature at all salient points, means P1, P2, P3, P4, T1, T2, T3, T4. All these things we have to find out. Mean thermal efficiency 1 minus QR by QS we have to find out. Mean effective pressure we have to find out. Thermal power, theoretical power we have to find out. We given is a cycle 210 working cycles per minute, change of entropy during isothermal expansions. All this we have to find it out. Now find out let us find out one by one pressure and temperature P1, P2, P3, P4, T1, T2, T3, T4. These are very important. In the beginning of the problem itself, they have given two values. P1, P2, P3, P4 we have to find. P1 is given. T1, T2, T3, T4 has to find out. T1 is given. T1 is equal to T2. Therefore, only we have to find T3 and T4. We have to find P2, P3, P4. So, 3 pressure values, 1 temperature value. If I find out, that completes the A determination. Now, how do we find out? Check out. That's what they were given. To find out P and T at all salient points of the cycle, we have to go with the calculation. First, given is a P1, given is a T1, T2. That's what I told. P2, P3, P4 is unknown, T3 and T4 is a unknown. Now to find out P2, first let us find one by one P2. P2 to find out, we have to go across with the PV diagram. 2 belongs to 1 to 2 process also, 2 to 3 process also. I can use any equation of these two process and find out P2. Now take isothermal process. What isothermal? Isothermal expansion process 1 to 2. 1 to 2. Now what is the formula for isothermal expansion? Isothermal always say PV is equal to MRT is a characteristics equation or ideal perfect gas equation. So where T is temperature, that is constant because it is isothermal. M is constant, R is constant. What is the remaining? Only PV. So PV is equal to constant. I can write, as this is two process, I can write P1 V1 is equal to P2 V2 is equal to constant. For isothermal, I can write it P1 V1 is equal to P2 V2 is equal to constant. Very important. Isothermal temperature is constant. So for full equation, PV is equal to MRT. M R is a constant. As this is a process isothermal, T is a constant. So complete MRT becomes constant. It is replaced by C. Therefore, the equation will become PV is equal to constant. So P1 V1 is, as the process is 1 to 2, I write it P1 V1 is equal to P2 V2 is equal to constant. So further, what can I write is, so I can write this one as in this direction. P2 we have to find. So keeping P2 here, I write P1 V1 divided by V2 is equal to P1. I separated V1 by V2. Is it given in the problem? Check out. There are two values given. One is V2 by V1 and another one is V4 by V1. Yes, I can use V2 by V1 value and find out. Here we have got V1 by V2. That's why the reciprocal is the value. Therefore, I take 1 by 1.5. you get the value of P2. Like this way, I find out the value of P2. Very, very easy. Only when you know all the basic equations of the each and every process. So P2 can be find it out by using 1 and 2 process. Now we have to find P3. How do we find P3 value? P3 value, go for PV diagram. P3 belongs to two processes. One is 2 to 3 and other one is 3 to 4. Adiabatic expansion formulas I can use to find out P3. Isothermal compression formulas I can use to find out P3. So what they have done, let us check out. Take adiabatic process. See first what they do. The previous process they use a formula, adiabatic expansion. Adiabatic expansion formulas are this: T2 by T3 is equal to V3 by V2. Always, how do you remember? How can you remember the formula? See, always the formula you can remember of adiabatic process is in this direction. There are two adiabatic processes, 2 to 3 and 4 to 1. So which volume is more in 2 to 3? Volume 3 is more. So in 4 to 1, volume 4 is more. Therefore, you can write the equation as V3 by V2, V4 by V1. What is the power? To the power of gamma. Next temperature, next pressure is equal to temperature is equal to pressure will be the reciprocal of it. So that's why you can observe here V3 by V2 to the power of gamma minus 1. In the place of V3, you write on T2. In the place of V2, you write on T3. So for pressure also you can write it as P2 by P3. Observe, this formula is very important for all adiabatic process. Always you can keep remember more volume to the lesser volume. The more volume for 2 to 3 process is a 3. So V3 by V2 to the power of gamma minus 1 is equal to T2 by T3 is equal to P2 by P3. But P2 by P3 I cannot write as it is. It will become to the power of gamma minus 1 by gamma. How this becomes P2 by P3 to the power of gamma minus 1 by gamma? You can observe here. P2 by P3 is equal to V3 by V2 to the power of gamma in the adiabatic process, that we know, because P2 V2 is equal to P3 V3 to the power of gamma. P2 V2 to the power of gamma, P3 V3 to the power of gamma is equal to constant was the equation. Using that equation, I will write on P2 by P3 to the power of 1 is equal to V3 by V2. Check out this V3 by V2. I will write out into T2 by T3. So writing down, this will become V3 by V2 V3 by V2 can be written as T2 by T3, or I can be written as P2 by P3. That's why I write it as P2 by P3 to the power of 1 by gamma. Finally, this will become P2 by P3 to the power of gamma minus 1 by gamma is equal to T2 by T3. So very easiest way. If you are getting confused, I will go for the derivation. In the derivation only I will show how we get it the value. Check out how we got this value V3 by Vt to the power of gamma minus 1. Check out, we have a two values P2 V2 gamma is equal to P3 V3 to the power of gamma is equal to constant, and one more condition, P2 V2 divided by T2 is equal to P3 V3 divided by T3. Now from this we got the equation P2 by P3 is equal to V3 by V2. Further, this equation will become P2 by P3 is equal to V3 by T3 is into T2 by T2 by V2. So where P2 by P3, I have substituted V3 by V2 to the power of gamma. Observe, P2 by P3 plus LE. The P2 by P3 what we have, I have substituted equation A, V3 by V2. Now what I do, I don't substitute P2 by P3 as V3 by V2. I keep it as P2 by P3 itself. P2 by P3 and then it goes again. But for V3 by V2, what we have here, V3 and V2, we have V3 by V2. I will substitute P2 by P3 to the power of 1 by gamma. Just a simple, very simple. P2 by P3, I will keep it as it is. So further, I will show it in the notepad. Wait for a second. So here we have a P2 by P3 is equal to V3 by V2 to the power of gamma, right? Now I have taken this as equation A. Now what we got in the notes, observe the notes. We also obtained P2 by P3 is equal to V3 by V2 into T2 by V2. Now the same equation here P2 by P3 what we have, instead of substituting V3 by V2 I will keep as it is. Keep as it is, that is P2 by P3 is equal to V3 by V2. V3 by V2 what we have, there I substitute P2 by P3 to the power of 1 by gamma into T2 by T3. This is T2 by T3. So like this way, now this whole power is 1. So what happens to do T2 by T3 is equal to, now this comes to the left hand side, this will become P2 by P3 1 minus 1 by gamma. So 1 minus 1 by gamma will become gamma minus 1 by gamma into T2 by T3. So T2 by T3 not only written as V3 by V2 to the power of gamma minus 1, it also can be written as P2 by P3 to the power of gamma minus 1 by gamma. So that's what the problem is shown. Check out here. T2 by T3 is V3 by V2 to the power of gamma minus 1. Also it is equal to P2 by P3 to the power of gamma minus 1. These two equations are same because left hand side is T2 by T3, left hand side is T2 by T3, V3 by V2 to the power of gamma minus 1, P2 by P3 to the power of gamma minus 1 by gamma. That is what I have shown here, how we got it. So in this, if I use, can I find a T3? So because I have to find P3 from this, how do you find out P3? So you can use this equation and find out. But if you use this equation, T2, T3 both should be known. But in the problem, I know T1 and T2. I don't know the value of T3. So to find out T3 value, what can I do? To find T3, consider the process 4 to 1. Simple. We have to find T3. I can use 2 to 3. Just now the equation I have used 2 to 3 equation, but I couldn't find T3 value. So further this 3 belongs to a 3 to 4 process. I go for 3 to 4 process and calculate the value of T3. So what is 4 to 1 process? Sorry, can be found out by using 3 to 4 process. So 3 to 4 process also if I use, I cannot find because isothermal compression process has only one equation, that is P3 V3 into ln of V3 by V4. So in that also I cannot find out T3. But you know T3 is equal to T4 from the TS diagram. T3 is equal to T4. Now as T3 is equal to T4, I can also go for 4 to 1 process. 4 to 1 process, that's what they have written. So to find out T3, they go for 4 to 1 process. You may ask why we are not using 3 to 4 process, why you are using 4 to 1? Because T3 is also nothing but T4. So that's why I can use T4 process, 4 to 1 process. Now using 4 to 1 process, the formula is adiabatic process, and the formula will be T1. Simple way you can take it. Which volume is more in 4 to 1? 4 volume is more. So V4 by V1, that's what here it is, V4 by V1 to the power of gamma minus 1. Next is reciprocal of that, P1 by P4, T1 by T4, but P1 by P4 is equal to gamma minus 1 by gamma. This is what we have written here. Now use any two equation, this value, as I have to find out T3, either you can use this value and you can find out. Now observe, if I use these two, I can easily find out the value of T4. That's what I have written over here. T1 by T4 is equal to V4 by V1 to the power of gamma minus 1. Given in the problem, V4 by V1 is 6. Substituting that, we can find out T4. So, but we know T4 is equal to T3. There, T3 is equal to 333.5 Kelvin. Obtaining this T3 value, I will substitute here and I find out P3. T2 is known, T3 is known, P2 by P3 we have to find. So how do you find out P3? P2 is just now we have find out before, that is 12 bar. Now that's why I substitute here for P2 value, I will find out P3. So like this way I find out P2, P3, T2, T3. Now all the temperatures are known. T3 is equal to T4, T1 is equal to T2. Temperatures are all calculated. P2, P3 is calculated. Last one we have to find is P4. How do we find out P4? Consider the process 4 to 1, that is adiabatic compression. The same equation I use. This equation I have to use for all adiabatic conditions. All adiabatic conditions ku ee formula use ಮಾಡಿ. Changing the numbers ಅಷ್ಟೇ. How do you remember this? Check out the volume, which volume is more. That volume, more volume by less volume is equal to less pressure by more pressure is equal to less temperature by more temperature. So like that way you can write down and remember the equation. So now, so that we have P1 by P4, the same equation I use it here and I can find out the value of P4 very easily, because P1 by P4, P1 is given in the problem, T1 and T4 are known. Use these two equation, only these two equation, and you can find out P4 very easily. That's what they have written. So check it out. Instead of that, they have used these two values. You can also do these two values, because V4 and V1 is known for you. So you can use these two values and calculate P4, or T1 and T4 is also known. You can use these two equation and you can find. So here in the notes they have taken the P and V values and find out P4. If you take temperature and P values, you will get a P4 value, then that will also be correct and it comes as 1.46. So like this way you can find out P2, P3, P4, T1, T2, T3, T4. All pressure, all temperature we have pointed out from each and every process. Now to find out thermal efficiency, formula is known, 1 minus T2 by so TL by TH. So T3 by T1 is the formula. You know the temperature, substitute and find out. Mean effective pressure, you have to remember this formula. Mean effective pressure is work done per cycle divided by stroke volume. So why the formula is written like this way? Work done unit is what? Work done unit is Newton meter. What is the unit of stroke volume? Volume, it is a meter cube. So Newton meter per meter cube. So what happens? Meter in the numerator cancels out with the meter cube. So we get Newton per meter square. The formula which we have written gives you the unit Newton per meter square. Newton per meter square is the unit of pressure. So that's why we will write the formula of mean effective pressure as work done per cycle to the stroke volume. Now, how do you write work done? So always you write down work done as Qs minus Qr. So how do you write down stroke volume? Stroke volume we will write it as V3 minus V1. So how you write it V3 minus V1? Now let's check out V3 minus V1. Compression process they have taken completely. Compression process they have taken completely. 1, 2, 3, 4. Which volume is more? V3 volume is more. Which volume is less? V1 volume is less. So V3 minus V1, what it gives? It gives a stroke length. So 1, 4, 3, if I take V3 minus V4. If I take V1, 2, 3, 1, 2, 3, you take V3 minus V1 is a stroke volume. 3, 4, 1, if you take V3 minus V1 is a stroke volume. That's what they have written. More volume to the less volume. The cycle is V3 minus V1 and Qs minus Qr is V. How do you find out Qs? You will find out Qs by using a formula P1 V1 ln of V2 by V1 using equation 1. Next P3 V3 ln of V3 by V4 using equation 3. With these two values Qs and Qr are calculated, substituted over here, mean effective pressure is find it out. So next is a theoretical power for 210 working cycles per second ಅಂತ ಕೊಟ್ಟಿದ್ದಾನೆ. Working cycles per second or some other values is that one. Working cycles per minute. So we have to calculate per second because the unit of power is kilowatt, watt is nothing but joule per second. So power is equal to work done per cycle into number of cycles per second. Work done, just now we have calculated QS minus QR into Newton meter is the unit we get. But I want to get Newton meter per second because joule per second, Newton meter is a joule per second is the unit of power. So how do you find out? Into number of cycles per second. Given it is in the minute, converting minute into second, 210 by 60. QS minus QR into 210 by 60. If I substitute, I get a value of P, that is 236 minus 236.81. Last one is to find out the change in entropy during isothermal expansion. How do you find out change in entropy? So observe the TS diagram because the entropy is present in the TS diagram. So you can find out S2 minus S1 or S3 minus S4 because S2 is equal to S3, S1 is equal to S4. So the difference in enthalpy will give you the value of entropy. Sorry, difference in entropy will give you the value of entropy. Now that is what they have written, S2 minus S1 for 1 to 2 process. So what is the general formula of entropy? General formula of entropy is equal to dq by dt, which you have studied in class S inequality statement and BTD. So dq by dt is a general equation for entropy, where dq by dt, how do you find? For 1 to 2 process, it is heat supply. Therefore, I can write P1 V1 ln of V2 by V1. Heat supply formula you know. Q andre heat. So heat andre heat supply, heat rejection. That for 1 to 2 process I have written. Therefore, it is a heat supply. Heat supply formula is P1 V1 ln of V2 by V1. As this is 1 to 2 process, 1 and 2 temperatures both are same. dt I can write it as T1. So delta S is equal to P1 V1 ln of V2 by V1 divided by T1 is a formula. But delta S is what? S2 minus S1. Now, is these values are all known? Yes. P1 is known, V1 is known, T is known, ln of V2 by V1. What you get is 0.192 kilojoule per kg is the unit of S2, is the value of S2 minus S1. So like this way we will find out the change in entropy during isothermal expansion. Expansion and when they have mentioned it is 1 to 2 process. If they have mentioned change in entropy during isothermal compression, then the process points will become 3 to 4. As it is expansion, it is 1 to 2 process. So for 1 to 2 process, you have written the formula and find it out.